Joe's Computer Museum.
Hey Joe, this is Javier. I think I have a busted floppy drive. Do you think you can help me?
Sure, anything for the Retro Bright Master.
Great, I'll send it right away.
I'll be waiting. Alright, so Javier sent me this drive in the mail to fix, to see if we can figure out what's going on with it and get it back up and running for him. So let's take a quick look. So what he told me it's doing is that it seems to be moving the drive head and doing all of that magic and spinning, but not booting anything. So let's actually just pop a disk in it, turn on the Apple II here and see what's going on. So here is a basic Pro-DOS disk. We're just going to pop it in there. I'm going to turn on the Apple II and see what happens. Well, first thing I can tell you is the drive is not spinning at all. It's humming, but not doing anything. There we go, and now it spins. But we can see that the head doesn't seek or anything, like it's not trying to load. And that just basically tells me that we have a motor issue. But let's keep diagnosing a little bit further before we just say, hey, the motor's dead. The fact that it didn't spin up, I had to touch it to get it to spin, kind of indicates that, but let's move on. So let's go ahead and pop this out and turn the Apple II off. So now let's see what next. Let's see if we can get the head to seek. Now, it looks like the head is already at track 1, so let's go ahead and move it up a little bit here, and then turn the Apple II back on and see if the head actually moves, just to make sure we got our brain box here is working correctly. Yeah, that seems to be working, so we do have head movement, so it is properly receiving commands from the computer. So it's probably just a bound-up motor. Now, if you've seen my K-Pro videos where I restored a K-Pro, you'll see that these half-height drives have a really bad habit. It doesn't matter what the brand, make, model is, but they have a really bad habit of the three-phase DC motor or whatever that's in it, the little flat pack motor that they put in there. They have a habit of binding up and just doing stupid things. So that's probably all that it is. We probably need to get in there and find some way to lubricate it to get this drive to work. There is one thing I do want to note right here before we start digging in, is the floppy, or not the floppy, the LED, the indicator LED here is folded back. And I did ask Javier, I was like, hey, have you been inside this drive messing about? And he's like, no, it just doesn't work. I'm like, he did replace the normally suspect 125 chip, and that didn't do anything. But no, he didn't take it apart or anything. None of the screws were removed. But this drive light is folded back. And what that tells me is, before Javier got this, somebody else was inside it trying to make it work as well. So let's see if we can have a little bit more success than they did. So next step, I want to actually confirm the drive rotation speed. And to do that, on the back of this, and we're lucky on this one, it has a sync disc that with a 60 and a 50 on here. So if we pulse a light at 60 hertz or 50 hertz, kind of like a timing light for when you're timing cars, it will, the little timing dots on the side of an old turntable, anyway, it will line up these little lines, and it'll be dead solid. It won't move around, and that's how you know that this thing is timed correctly. So let's rig up a 60 hertz blinky light thing pointed at this and see where we are. Alright, so what is this crazy contraption here? Well, this is my timing light, basically. It consists of multiple different pieces. We have an LED rigged up here that I have kind of off screen. You can't really see it over here through a resistor, so I don't kill the output of that, or I don't kill my LED. And this right here is a little function generator that will generate square, sine, and triangle waves at a different selectable frequency. Right now I have that frequency set at 56.8 hertz, or close to 60. I wanted to get it close to 60 and then dial in the knob to see how close we actually have to get to 60 to see what this is. Now, of course, as you can see here, we're trying to sync it up to the 60 mark or the 60 sync marks here. So when this is synced up, basically what you'll see is right underneath this light, you'll see just a solid black line. So let's go ahead and turn this on. And we want to test it with some drag in it. So we want to test it with an actual floppy in there. So we're going to put that in, and then we are going to put the floppy in there. And let's tune this a little bit. That's a little too slow. I'm turning this knob very slowly until the little lines stop moving, or get as close to not moving as I possibly can. That's pretty close. It's about as close as I'm going to get it. So now, this is pretty close to synced up here. It'll be a little bit hard for you to see in the video because the video frame rate doesn't match the flicker rate here of this light. But the little black bands are moving backwards very, very slowly in the counter rotation direction, which tells me that my sync is close. It's not perfect, but it's close enough for our testing purposes. So I have this also hooked up right here to my oscilloscope so that I can see what frequency is being output by this function generator. So I'm going to look over here, and I can tell you right now it's outputting 56.8 hertz. Apparently my test setting was perfect. So looking at that, that means that because this function gen is spitting out 56.8 hertz, i.e. it's slow, that is spinning too slowly. So that means we need to speed this up somehow. That just basically proves it's bound up. Now, there are a couple of different things we can do. These guys have, this one's hard to see, but right here is a tiny little trim pot in the motor controller board that will likely speed this up. But I don't want to simply rely on that. I did that with the K-Pros. I sped them up and they worked great. And then a month later, they had failed completely no matter what I tweaked that pot to. Basically because the motor burned up or it got bound up or whatever happened to it. So we want to actually get this thing apart, see if I can get underneath this motor to this spindle bearing and lube the spindle bearing up. I don't know, sand it a little bit so it's a little bit smoother. I don't know what we have to do, but we'll figure that out once we get inside there. So let's get cracking. Alright, now that we have everything taken apart to where we can get to the actual spindle motor, I got everything set back up again to test the speed of the motor. The reason we're doing that is I want to get a baseline for what the speed of this motor is before I try to get the spindle out and lubricate the center bearing, so that when I put it back together I can test that speed again with a known frequency setting for my signal generator, and I'll be able to tell if I've sped up or slowed down this motor with that when it doesn't have any drag on it. It gives me kind of that scientific control, that baseline. So we're going to go ahead and turn on the Apple II, get this thing spinning. Everything's kind of very tenuously arranged here to be able to do that. Then I'm going to tweak the meter over here and check and see what the speed is. We're going to jot that down, and then when I get the drive lubricated and put back together, we'll be able to know, did I fix it or not? So let's do that. So we got that spinning. So I'm going to adjust this until I get it as close to whatever as I possibly can. That's way too fast. Too slow. Now this takes a little bit of effort to get it just right. That is pretty darn close. It's about as close as I'm probably going to be able to get it. And that is 63.3 hertz. Now, that's faster than what it was when we had the drive in it. That's because the motor is not loaded down. There's no drag on it. So that is going to be normal. So let's write down 63.6 hertz. I'm just going to put that over here on my computer. 63.6 Hz. Unloaded before fix. Okay, so we have that documented now. Now let's see if we can get this thing apart and get inside that bearing and get it all lubricated. All right, so taking this thing took way longer than expected, mostly because of lack of brain power, but that's okay. So I just want to do, I didn't do that on video because, again, it took forever and I didn't want you guys to laugh at me fuffling about trying to, no, I just forgot to hit record actually, but that's fine. So what we have here is the different bits and pieces required to get the magnet part and the flywheel off of this. Basically, this sits down there on there like that, pretty tight, and underneath the sink stripey thing here were some screws that I had to find. Take those screws out, and this, and then you could pry up on this with your pokey pull tool because it magnets on there really, really tough. And, of course, I stuck it on there like a moron, and now you get to watch me faff around and get this off of here again. But I guess we'll just recreate the process. Stick some pokey tools underneath here, and then it comes off. And then the magnet comes off of there. And then what you're left with is this brass bushing here that is press fit down onto the little cylinder thing. Now, that screw is just on there to keep things from flying off. I just put it in there so I wouldn't lose a screw. Same with these screws. I just put them back in there so I wouldn't lose it, but that's on there. This was a similar process. It was on there really tight, and I had to pry up with lots of different tools to get that off of there. This was the toughest bit to get off there. As you can see, I kind of chowdered it up a little bit, but it's off of there. And now we finally have access to the actual bearing. Now, I wanted to get the entire spindle, the entire top half of this motor out. I removed these screws and very carefully tried to pry it apart so that I could see if I can get into the bearing itself, because bearings are pretty universal. If I could find an actual replacement bearing, that would have been really, really cool. But I couldn't get this apart, and I also had to be very careful because of the coil wires here would come off with that, and so I decided not to try to take that apart. I figured we would use some penetrating oils and stuff to get down into the bearing and hopefully lubricate that. While I was in here, I noticed some very interesting artifacts of this device. First off are these bodge wires. These wires were bodged in from the factory, most likely. You can tell because it's magnet wire or coil wire, not actual like rework wire. So that's one thing. It's all cross-connected with these capacitors here going off into whatever. My guess is because this internal mechanism is actually a PC floppy drive mechanism, at least the motor drive system is, and they may have modified it to change the rotational speed to get it down to the Apple II spec. I don't know. That's just a guess. I did trace all of these out, and they all have interconnections on both sides of the board. So this should not be our problem. But one thing I did notice is right here, there's some corrosion right here on this capacitor, on the back side of this capacitor. And if we flip it on the front side as well, there's also some junk down in here where this capacitor is likely gone kaput and has leaked its contents, which, as we know, will cause the capacitor to not work correctly. I traced this out, and it goes off over here to this IC, which is the motor controller chip, or the driver chip for the actual motor itself. So I'm thinking if this capacitor, which is part of is related to this decoupling capacitor and this inductor here, it's probably just part of the buck regulator or cutoff circuit to prevent backfeed going back out the power. But in any case, it is busted. We're going to go ahead and replace it just to give this drive the best chance of working correctly. So we're going to take that out, get a new capacitor in there that I had to order and get in, and we'll see what does. Well, that was a pain in the patoot. This capacitor, when it died, corroded the heck out of the solder so much that I could not get that solder to melt or anything. So I had to put the positive lead in there, and then I had to scab the negative lead around the board to the same point on the board. And then because I had applied so much heat there, I wanted to double check. So I used my my multimeter to check and make sure that I had signal on both sides of that. And I did, so things should be good there. So now let's do a little speed run of putting the motor back together and then doing an actual speed test compared to my pre-disassembly and lubrication, so we can see if we actually improved the prognosis of this drive. All right, well, we got it all put back together, at least enough to spin the motor. And while I was putting it back together, I did notice that the spindle seemed to spin a lot more easily after the lubrication. Hopefully that fixes it, and my bodge didn't break it, so that's, I guess, a good thing. Although I am testing it, I'm still getting the same speed out of it that I was before as far as the spinning rate, and that may, again, just be directly a direct correlation to how the potentiometer, the speed pot here, is set up. It's auto-regulating would be a guess, so it doesn't really matter. The one thing I also noticed quite greatly is that the before, when you would turn the power onto this, it would kind of struggle to get started and spin even when it was unloaded like this, and now it fires right up, so that's a pretty good thing. So now let's get it all put back together, connect it up to the Apple II proper, and see if it works. Alright, now we have the moment of truth. It's all put back together, hooked up to the machine. Now we just got to put a disc in it and see if it'll run. We have a floppy right here. It just has a good old DOS 3.3 on it. So we're going to boot it up, see what happens. Ha ha ha! It works. So that tests the read function. Now let's test the write function by doing an init. So, init hello. Uh-oh. Well, that doesn't work. What could that be? Well, it might be a write protect problem. So let's try jumpering that. Okay, got a lead here. We're going to jumper across the write protect sensor and see what happens. So let's turn the machine up. That's the wrong thing. Let's turn the machine off real quick. Get some tools to do this. All right, we will get the sensor out first. And then let's get the little thingy out of here. The connector shroud, or whatever you want to call it. That's out. And we'll put this jumper lead across those, which make the thing, make the system or the disk drive electronics think that the write protect is always on or off. You know what I mean? Okay, let's turn this on. That works as expected. And will it initialize? There it goes. Ha-ha! We have a fully fixed drive. That is really awesome. So, just to synopsize what we had to do to fix it, we had to lubricate the drive motor, replace a capacitor in it, and that seemed to have just fixed the problem. That is awesome. Well, I'm going to get this thing boxed up, shipped back to Javier. I hear he's got some really cool things he wants to do with it. But actually, before I box it up and send it back to him, I should probably, I don't know, put a permanent jumper across that. I'll do that before I get it put back in the box.